Sorry, I'm gonna leave. I'm driving so far. Tell me why you coming to me and say you want me again. Never wanna lose me, 'cause I'll be missing you. 뒤돌아봐도 결국 또 너야. 난 그래서 네가 좋아. 또 내게서 멀어져 갈까봐 조심스러워. Never enough, just for a night. I got a lot of things gotta tell you all night long. Promise I'll never leave you alone again. Take you into my loving arms, and I'll look into your eyes. Then I'm gonna whisper just how beautiful you are. 만약에 네가 잠시
This is the data for mean, variance, and standard deviation for set 1 leaf length. Next is about data for set 1 leaf width. Next, we move to the data for set 2 leaf length, while this is the data for set 2 leaf width. Next, we move to the data for set 3 leaf length. Lastly, this is the data we have obtained for mean, variance, and standard deviation for set 3 leaf width. Question 1. Discuss the difference or similarity of the mean of length between different sets of leaves. Do the same for the mean of height. The mean leaf length of 3 sets of leaves vary, possibly due to errors during leaf collection. The upper part of dense plants canopies of flowers may be smaller, allowing better light penetration and reduced shading. This adaptation also reduces wind resistance and conventional damage, ensuring structural integrity. The mean height of 3 sets of leaves was similar except for set 3. This could be due to tightly controlled environmental conditions such as light intensity, humidity, temperature, and water availability. Plants may develop broader leaves for optimal photosynthesis in evident environments, while narrower leaves may reduce water loss or surface area exposure.
We will discuss about practical one question, which is what means of value variance. Variance means value of square mean of the value. And then, why the leaf have different measurement of width and length? The leaf have different measurement is because of we get the leaf from the three different parts of plants. In the same plants, but we divide it into 3 parts. So that's why we get different width and length. And then, based on the experiment, there are 10 leaves were picked up of each set, which 3 sets in total are equal to 30 leaves that has been taken. So as in set 1, the value of variance in length and width is 3.26 and 0.51. And then for the set 2, 5.16 and 4.96, and last set is 504 and 0.98. So the value that is entered showing the length and width for the leaf have different measurements. So the definition, and then the definition of standard deviation. Standard deviation is a measurement of how much a group of data varies or is dispersed. So it can also be used to illustrate how the measurement for a set of data are dispersed from the mean or average. And then the low standard and high standard are the 2 categories into which standard deviation is split. Values with low standards are closer to the mean, whereas the value with the high standards are more widely distributed.
For question number 3, why it is necessary to have different sets of measurements for the measurement of leaf width and length? It is necessary to have differences of measurement of leaf width and length because to know either the characteristic of plant is same or not, also to get a valid data and average measurement of leaf.
잠시 어디론 갔던 나야만 한데도 괜찮아 우린 언제든 그대로일 테니까 기다린 순간을 참아왔던 고백 뻔하지만
Here are our quadrant samplings result. We made two set. For the practical two set, different shape refers to different types of plants. And see the observations. If the second one refer to the Neobalanocarpus hemi, which has two, and then the triangle refers to the Shorea ovalis, and then number 3 Adenantera pervenina, and the left one is the Terminalia catapha. So only the Neobalanocarpus hemi that the second one has two species. So the density number is 0.04. For the rest, the density number is 0.02 because it has one species number, because we just doing the quadrant in a small quadrant, just 7 times 7 meter, 7 meter times 7 meter. Here are the quadrant sampling practical 2 set 2. Also same like the set 1, we made 7 meter times 7 meter, and then we got 4 species type of plants, which is different species. As observation, we can see that the flowers one, Hopia odorata, and then the rectangle, we can see the square, we can see the Garcinia astroviridis, and the triangle Petaspenia motley, and then the left one is the Neobalanocarpus hemi, and then the total number of species for this all in a quadrant is only one, and then the density number is 0.02.
Next, we continue with the post-lab question practical 2. The first question is to define the term quadrant in practice. A quadrant is an ecological sampling unit that consists of a small square area of ground, where all species of interest are identified or measurements are obtained. It is accomplished by counting all individuals on quadrant of known size and then extrapolating the average count to the entire area using the diversity index or relative density formula. The next question is, what are the two basic requirements of all the quadrant techniques? The first one is the area of the quadrant must be known so that the density is determined directly. The second one, the organism must be immobile during the counting period to ensure they are counted and not missing. The third question is, what will be the advantage and the disadvantage of using a larger or smaller quadrant to supply a sanitary organism? The benefit of using a bigger quadrant includes greater sample size and more accurate estimation of overall densities, while its disadvantage include increased times and labor needs and the inability to handle localized or patchy distributions. The benefit of using a smaller quadrant includes more precise sampling and suited for small-scale patterns, while disadvantage includes a small sample size and missing too many individuals to count, resulting in an underestimation of the real population number.
Okay, so to answer this question, so since it is difficult to sample the entire population in steady area, such as in forested and aquatic habitats, smaller community or population samples should be taken. So the problem then is how to estimate ecological systems parameter best considering limited time and resources. So the sampling problem can be divided into various issues. So the first issue is to find the sampling method that can be used to obtain the required data. And the second one, to find the method for selected sampling locations to minimize potential bias and provide the best estimate of target parameters. And last one, method to reduce the number of samples taken while still providing accurate parameter estimates. Okay, so to answer these questions, the assumption that we can make as to why there are differences in the number of plant species in the quadrants are due to several factors. The first is maybe due to the differences in microhabitats within quadrat state may result in varying plant development conditions. So some areas may have higher sunlight, humidity or nutrient availability than others, that allowing certain species to survive in the area compared to other areas around it. And next, the distribution of plant species can be affected by changes in soil composition, pH levels, and nutrient content. Some plants may do well in certain soil conditions, while the others may struggle or die. In addition, the competition between species for resources such as light, water, and nutrients can also limit the number of species in a quadrant. Dominant species may outcompete others, resulting in a reduction in overall species diversity. Disturbance is also one of the factors why there are differences in the number of plant species. Plant diversity may be affected by recent disturbance, such as human activities, natural events, or invasive species. The disturbed areas may have fewer species because of habitat degradation or changes in the environmental conditions. Other than that, quadrat can contain various levels of ecological succession. Early successional stages may contain few species, but mature or climate communities may have greater species diversity. Last but not least is because of historical factors. The current distribution of plant species in a quadrat may be influenced by past land use, historical disturbance, or geographic consideration.